this video on optics experiment prepared by Sir Arvin, Jusi, and Dr. Rhea Mero.
Welcome to the second part of this workshop. Here, we will show you how to use your phone to do experiments with light. Particularly, we will demonstrate the inverse square law for light intensity, reflectance, transmittance, and absorbance. There are several smartphone applications you can use to perform experiments involving light intensity. But in this part, we are going to use the application called Physics Toolbox. According to the creator of Physics Toolbox, it allows you to turn your mobile device into a research tool. We will first demonstrate the inverse square law experiment. Light carries energy as it moves through space. This transport of energy is characterized by its intensity, which is defined as the power delivered by light per unit area. This quantity is known to obey the inverse square law, shown in this relation. The objectives of the experiment are measure the light intensity of a light source using a smartphone and Physics Toolbox application, and verify the inverse square law for light intensity. The materials we are going to use are meter stick or ruler, flashlight or any light source. You can also use the built-in flashlight in your phones, and a smartphone where you install the Physics Toolbox application. Arrange the materials according to the diagram of the setup, and then vary the distance between your phones and the light source. You can move your phone, or you can move the light source. Physics Toolbox will automatically record the measurements as soon as you start the experiment. However, you can always manually record the measurements in a spreadsheet and use the spreadsheet to analyze your data. Next is reflectance. Light is composed of different colors, and each color has a unique frequency or wavelength. When an incident light hits a material, some colors will be reflected, some will be transmitted, and others will be absorbed. For example, plant leaves reflect green light and absorb all the other colors. This is why leaves appear green to an observer. The objectives of the experiment are measure the light intensity of a reflected light from a surface with different colors using a smartphone and Physics Toolbox application, and determine which colors make the surface more or less reflective using the measured light intensity. The materials we are going to use are white paper, black colored paper, and art papers according to the 7 major colors of the rainbow, flashlight or any light source, and smartphone where you install the Physics Toolbox application. We will first measure the reflected light intensity from a white paper, then from the colored papers, and lastly from the black paper. Arrange the materials following the diagram of the setup, and then measure the light intensity from each paper. Physics Toolbox will automatically record the measurement as soon as you start the experiment, but you can always manually record the measurements. Lastly, we will demonstrate transmittance and absorbance. First, let's introduce Beer-Lambert's law. When light passes through a solution, some of the light will be transmitted, while some will be absorbed. This means that the transmitted light will have less intensity than the incident light. And using Beer-Lambert's law, we can calculate the absorbance of the solution. The objectives of the experiment are Measure the light intensity of light source passing through a material using a smartphone and physics toolbox application, and observe the transmission and absorption of light. The materials we are going to use are, for part 3.1, art paper or cardboard, a hole puncher, and for part 3.2, water in a clear bottle, sugar or juice powder. For both parts, we're going to use a flashlight or any light source, and a smartphone where you installed the Physics Toolbox application. Arrange the materials according to the diagram of the setup and place the paper or the solution between the light source and the sensor or your smartphone. Create holes in the paper and record the intensity of the transmitted light corresponding to the number of holes, or increase the concentration of the powder solution, then record the intensity of the transmitted light corresponding to the concentration of the solution. Hope you enjoy doing the experiments.
All right, so why don't we give a virtual round of applause for Sir Arvin and Dr. Rhea for their presentation. And before we have them for the open forum, we will first be having our pop quiz again. So the rules are the same. Whoever sends the answer correctly in the chat box will be the winner. So can I see a thumbs up if you're ready? All right. Okay, so the question is, most smartphones today have front and rear cameras. When using the physics toolbox, which camera is used as the light sensor? The front, the rear, or either? Is it the front, the rear camera, or either? There are a lot of answers being sent here sa Zoom chat box. So the correct answer is either. So it depends on the phone. So you have to discover it. So nasan ba yung sensor ng phone natin? Kung nasa front ba siya or nasa back. So you can use either the front cam or the rear cam. Okay, so let me see. The first person to answer correctly is Kevin Cuarta. Kevin Cuarta. So can I ask you to turn on your camera? Kevin?
Yes po, ma'am.
Hello, Kevin.
Hello po.
Introduce yourself quickly. Are you a student or a faculty member?
Hi, I'm Kevin Cuarta po. I'm a faculty of St. Peter Perona Academy Incorporated sa Hermosa, Bataan po. I'm currently teaching Science 10, no? Pero I was able to teach Science 8 to 10, also go Physics 12 and Earth Science subjects.
Wow. So thank you, Sir Kevin, and congratulations po once again. So a representative of Filipino Science Hub or FilSciHub will message you for your prize.
Thank you po.
All right. Thank you, Sir Kevin. And now we're ready for the open forum. So let's call on Sir Arvin. So I think Dr. Mero is not able to attend here with us today. So Sir Arvin?
Hello po, good morning. Before I answer questions from the audience, so let me just clarify. So because our smartphones today have front or rear cameras, then if you try to use the front camera and the physics toolbox application is not responding, then most likely you have to use the rear camera to measure the light intensity, or vice versa. So if you're using the rear camera and the physics toolbox application wasn't responding, then you should use the front camera. So the answer is either, yeah. So you just have to discover.
Thank you, Sir Arvin. So are there any questions? Any question from the participants?
There's a question here. Sorry, ma'am. There's a question here in YouTube. Okay. live chat. So, offline po bang apps na ginagamit nyo? Okay, yes po, you can install, you can download it from the App Store or Google Play Store, and then you can use it offline afterwards.
Okay, thank you, Sir Arvin. So, just a confirmation, do we need to do this experiment in a dark room?
Not necessarily, but I think the results will be better if you're doing it in a darker room. Okay?
Yes, sir. Sir, there
Because
are...
sorry, because
Sorry.
the light intensity coming from your light source, I think it will be much greater than the light intensity coming from the ambient light from the room. But yeah, I think if the room is darker, then you will have better results.
All right. Thank you, sir. Sir, there are questions here about the graph. So in the graph shown, why is the linear fit used?
Okay, so as you can see, wait, maybe I can show you the. Okay, so this is the inverse square law. So as you can see, inverse square law states that the intensity of the light is proportional to the inverse of the square of the distance, or the intensity is inversely proportional to the square of the distance. So if you are using in the plot, maybe again I'll show you the plot using my video.
All right, sir. While we are waiting for Sir Arvin, can I see a heart burst from our participants if you're enjoying this talk so far? Ayan, so dami nga naman talagang nating natututunan dito sa event, right? So I hope this second session will also be as interactive as the first session. So I can see a lot of questions being sent here sa chat box. So we will answer them one by one later.
Okay, so can you see now? So as you can see here, what I used in the x-axis is the square of the distance. Okay, so not the actual distance. Okay, so it means that according to the inverse square law, okay, so this is the inverse square law. Yeah, so we have that square of the distance is inversely proportional to the the intensity is inversely proportional to the square of the distance. So the relationship of intensity and the square of distance is linear, okay, and and linear but inverse. Okay, so inverse linear relationship. So as you can see here, if we plot the graph of intensity versus the square of the distance, then we have a linear relationship, and we have to use linear fit to uh, to see the best fit curve, the best fit curve or the trend line.
Yes, sir. So it really depends on the axis, right, na gagamitin.
Yes, if you're using distance only, so the relationship will not be linear anymore. Okay, so you're going to have to use another fit. Okay,
Okay, sir.
so I hope that's clear.
All right. So thank you very much, Sir Arvin. The next question po, what's the difference between FFox and Physics Toolbox? So a lot of questions are about the apps that you used, sir. So iba to dun sa ginamit kanina. So is one app better than the other depending on the experiment?
I think it will depend on your preference. If you like the UI of the the FilFox better than the Physics Toolbox, then you should use FilFox and vice versa. And then I think they will just use the same sensors, right? Or for every measurement. For example, you're going to use light. You're going to use light intensity meter or the gyroscope in both applications. Then I think they will just be using the same mechanisms, right, to access the sensors in your smartphone. Okay. So I think the only difference will be the user interface and what and if you prefer the UI of the other app than the other, then you should use that app.
But they are both free, sir, right?
Yes, but however, there are some ano nga to? There are
Sensors, sir.
some sensors that I think you have to buy or you have to pay to use it, parang ganun.
Okay, sir. So can we use our phones and the app? I think the participant is referring to the Physics Toolbox app for measuring the intensity of UV radiation. Can we use our phones and the app?
UV radiation. I think it will depend on the capability of your camera because the application will use the phone of our camera as the sensor. So if your camera can detect UV, then you will see that the application will respond to UV light. But if it's not capable of detecting UV, then it will not respond to UV light. I mean, the application will not respond to UV light. Gusto ko lang po sagutin, ma'am, itong tanong na dapat 1/square ng distance. So, kapag po ginamit nyo, sabi ko is, di ba sabi ko nga is, dito is, I just share my screen again. So as you can see here, this is the inverse relationship, the inverse square law relationship. So if you're going set the x-axis as the square of the distance, then the relationship will be inverse linear. But if you're going to set the x-axis, so let me draw, okay, the x-axis as the whole 1/r squared, then the relationship will be linear. So your plot will be like this. It's not inverse linear. Okay? So kapag po 1/r squared yung ginawa mo yung x-axis, yan, so S, so the relationship will be linear positive relationship or direct relationship, right? Then if you're going to use r squared as your x-axis, then the relationship will be, as you can see here, will be inversely linear. Inverse linear. And then if you're going to set the x-axis as r only, not the square, right? So I think the shape will be like this. Yeah, I mean, it's not going to be linear at all. Yeah. So ganyan po yung ano. Then if you're going to analyze your plot, then you just have to use the appropriate curve fitting method. Okay, for example, this one is not linear, then you should not use linear fitting, right? Then if in these two plots here, you can use linear because the relationships here are both linear. Okay. So I hope that clarifies po.
Can I ask? Can I ask clarificatory question?
Sino po? Sorry, I stopped.
Is it all right? I think the main error in this experiment is the assumption that the light source is a point source. 1 over r squared relationship with the intensity only holds true if the light source is a point source. Now, the students will be confused because what obviously appears on the plot is not a straight line. It's actually a curved line. So my suggestion is, instead of assuming a 1 over squared relationship, just study the actual relation. It will come out not to be 2, but it's a bit less than 2, about maybe 1.8 or 1.7. So that's my suggestion in this experiment. Don't assume the 1 over r squared relationship, but analyze the data as is and get the actual relation. Thank you, Arvin.
Yes po. Thank you for your suggestion, sir. So, for this demonstration po, so we just want to see that we just want if you're doing the experiment, for example, the students, the teachers, they will demonstrate the experiment. They will demonstrate the law, the inverse square law. So it's the actual objective is just to see that as you increase the distance, as you can see, the intensity will decrease. So actually, that's in the worksheet po na we have to it's in the worksheet po. Ito kasi po is ano lang, an example ko lang po dito sa aking slide, because we have to show also for them to follow the work. I mean, for them to be able to follow the steps in the worksheet po. Yan po.
Okay. Baka hindi na lang tawagin na inverse square law. Like effect of distance on the intensity na lang, ganun. Para they will not be forced to really see the inverse square law.
And meron po din, naglagay din po pala ako, sir, ng measure dito na r squared na 0.964, which means that the relationship is fairly linear. Parang gano'n na lang din po siguro. Pero, yes po, tama po kayo, sir. Very useful po yung inyong suggestion. And so, dapat po, yan, para nga po maging, para maging ano po talaga yung inverse square law is, sabi po ni sir, is dapat is a point source, parang laser po. However, because sabi nga po ng ibang mga nag-chat dito is, some laboratories or classes don't have enough resources. So we just have to use what's available to us. So if we only have phone cameras, phone flashlights from our phones, then at least we can see the effect of the distance, okay, with the light intensity. So tama po kayo, sir. Thank you po. Suggestion.
Thank you, Sir Arvin and Sir Ivan. I think Sir Nell is raising his hand. Sir Nell, you can unmute your microphone.
Yeah, hello Ivan. Of course, yung sample activity lang yung pinakita, but you can really do a different or so many activities na pwedeng gamitin yung light source and then yung camera. And it's good na mention mo yan because really ang ibig sabihin kasi nito is you can really do this for research, no? Hindi lang dun sa canned experiment sa classroom. Dahil kung makikita mo dito, talagang kung magme-measure ka ng totoo, no? Like yung talagang makikita mo sa light source kung lumalayo siya and so on. And there are a lot of other things that you can do na yung parang research style, no? I think it's one of the good things na dapat gawin sa estudyante ngayon even in the lab. Now, we try to do experiment na hindi yung parang susunod lang tayo sa law na available kasi parang yung canned, we need to sabihin sa estudyante na there are things na you have to do research and we might not get yung totoong data. And as long as we can explain bakit ganon, then it will be alright. And I think that would be a good parang basis na ma-develop or something na trait ma-develop sa students natin, no? Hindi tayo dapat parang restricted doon sa, alam na natin kasi itong mga laws na to, nandiyan na siya, pero we can really look into, parang research style.
Can I just maybe add one more thing about, kasi may experiment kayo na maganda about reflection ng different colors. Ang ano ko lang dito, kasi ang unit na ginagamit ng smartphone ay lux, LUX. So ibig sabihin yan, ang sensor na ginagamit, yung light sensor, ay very sensitive to the wavelength where the eye is most sensitive, na bandang yellow-green yata. So yung sensitivity niya sa red at saka blue, naiiba. So baka when you measure the reflection of the red, and you measure the reflection of the blue na surface at saka measure ng green surface, baka magkaiba dahil yung sensitivity ng sensor na ginagamit ng smartphone ay wavelength dependent. So isa rin yung i-consider ng estudyante regarding the actual data that he or she gets. Thank you.
All right. Sir Nel?
Yeah, maganda yung suggestion ni Sir Ivan. Kasi you can really find out kung sa lux meter or if you have access to the camera information, you can take a look at yung parang characteristic wave, characteristic curve niya. So makikita mo doon sa characteristic curve, sabi nga ni Sir Ivan, no, sensitive siya doon sa green, medyo mga 555 nanometers yun eh. So ang curve niya parang parang bell curve. Ang lalabas niyan pag tiningnan mo yung lower wavelength, higher wavelength, mababa yung niya parang tinatawag natin yung makukuha mo intensity. So you can really calibrate that, and also parang yung data mo parang normalize mo para pwede mo nang gamitin na as if pare-pareho yung response nung different wavelengths. Of course, maganda yan kasi students can try that, no? Marami kang pwedeng i-explore na gawin para mapaganda mo yung makukuha mong measurement.
And also, I just want to add, ma'am, dun po sa worksheet, we ask the students or the experimenter to answer the question. Why is it recommended for us to wear, for example, light colored clothes during a sunny day? So parang, and by demonstration of that, using art paper and the reflectance of those art papers, maybe they can also answer that question. So parang ganun. So it's not actually really the yung sa reflectance na following the yung parang, because it's sensitive to the light meter, is sensitive to is sensitive to the yellow green na color. So parang siya, parang hindi na po magiging effective yung demonstration. So parang just to din po, magkaroon lang din po sila ng idea kung bakit nga po ba tayo nire-recommend na to wear, for example, to wear light colored shirts during sunny day, parang ganun po. So parang ganun po siya. So parang sana po yung mga magpe-perform experiments, so tingnan lang na lang po nila yung mga objectives sa work.
All right, thank you, Sir Arvin and Sir Nel. So we just have a few more questions here in our Zoom chat box. Sir, to clarify, no, free app din yung Physics Toolbox.
Yes po, yes.
Okay, so free app siya. And do the students have to have a prior knowledge on how the sensors work for them to better understand the experiment?
um, based from our ano po, from our initial parang nag-ano din po kasi kami, di ba? Katulad din for demonstration, we also perform the experiments. And also, yun po, meron pong mga experts tayo dito na nagbibigay po sila ng useful suggestions, di ba, about dun sa experiment. So, however, to answer that po, yung prior knowledge, I think readily, you can actually perform the experiments without prior knowledge. Okay? And also kapag din po pumunta kayo dun sa mismong website ng Physics Toolbox, I will chat here. Ay, hindi ko makita ko nasa. Ayan. So, meron din po silang mga demonstrations dun and tutorials. So, you can actually, before, if you want to have prior knowledge na din nga po, so you can actually check their website and tutorials there. They also provide different worksheets and different sample experiments dito po sa website nila. So, parang kanina po may question, di ba? Na is there an experiment or lab activity instruction readily available together with the FilSciHub app? So, sagutin ko po siya dito sa Physics Toolbox naman So if you follow this if you go to their website, so they will actually provide some activities din po and lab activity instructions din po for simple experiments using the application. And are there available video tutorials for other experiments? So yes po, dito sa website po, you can also see dito po sa sa kanilang website. So ayun po yung sagot ko dun sa prior knowledge. So I think ang sagot po diyan is without prior knowledge, you can readily use the application to perform the experiment. I mean, just by following the lab activity guides provided for example, in the worksheet na given to us by FilSciHub, or itong galing po sa website. So, ayun po. But if you want to have prior knowledge na rin nga po, so yan po. Just visit the tutorials here in the Physics Toolbox website.
Yeah, Arvin, there are also many parang sample na activities that you can find on YouTube, no?
Yes po,
maganda sa explore.
Opo. Yes
Ang
po.
dami-dami
In YouTube also.
Yes.